Welcome to Math 104, Chapter 7.1 and 7.2. We are doing these sections together because they flow pretty nicely and they can be used simultaneously. So after we have watched the 2.3 lecture where we talked about systems of two with two variables, we're now stepping it up with three variables. So if we're going to be doing it algebraically, we want to make sure that those foundations are strong before moving on to this section. So below, to the side, we have your steps, and this one, we're not filling them, they are not completed, so we're going to be filling them out. Now, as we go, each step that we're going to be working with, we're going to be prompting you guys, and I'm just going to follow along with what my previous class has done. So it says, the first step, we're going to pick two equations. Now, it doesn't matter which ones we choose. So we have three equations here, and we're just going to pick two of them. Now, my first class, or my previous class in person, we picked x minus y plus 2z is equal to -3. Don't know what just happened. -3. Now this is going to be that middle equation. And then they decided to pick the one below it. So 3x plus y minus z is equal to 9. Now, any idea as to why they may have picked it? Any inkling? Maybe it has to do with something that we are going to be canceling out. So with the three variables, substitution is possible, but it is very challenging. So we're only going to be working with elimination. So we are now going to eliminate a variable. So which variable will eliminate easily without even having to manipulate our answer or our equations? Well, your y's are going to cancel. So we're going to combine your like terms. We have 4x plus z is equal to 6. Now we are going to save this equation for later. So we're going to highlight, box, do something that brings your attention to it that says we are going to save this equation and bring it together later. Save the new equation for later, box, star, highlight, you name it. So now we're going to go back and pick two different equations to work with from the original three. So one of them will have to be the exact same one, but we can pick one other one. So again, looking at the three, what ones do we want to work with? Well, my class, again, chose this bottom one and this top one. So they chose, let's see, 2x minus 3y plus z is equal to -1. And they did the last one, 3x plus y minus z is equal to 9. So those are the two that they have chosen. So now we are going to eliminate again. Now, before we get too hasty and eliminate our z's, we do have to eliminate the same variable as the one we have done previously. We chose to do y previously, so we're going to have to work in getting our y's canceled. So you do not have a choice. You will create a new equation though. So how can your y's cancel? Well, they do have opposite signs, which is really nice for us. And it is kind of easy to get this y to become a 3. So let's go ahead and multiply this and this both by a +3. Be sure to distribute that 3 throughout your expression. So we have 2x minus 3y plus z is equal to -1. That is your first equation. Times now 9x plus 3y minus 3z is equal to 27. Now we're going to go ahead and see if these eliminate. If we did it correctly, we can eliminate your y's just like that. And now we can combine your like terms. 11x minus 2z is equal to 26. We're going to save that equation just as we did from previously. So it says with two new equations, the two saved equations, we're going to further eliminate. So let's stack them up on top of each other. Now I'm going to move this a little bit so that it's kind of underneath to the side. Okay, so let's bring these two equations together. We had 4x plus z is equal to 6, and 11x minus 2z is equal to 26. Now, have we seen something like this before? Yes, we have seen this before. This is exactly 2.3. So pause the video, see if you can take it away from here. Now, I'm a fan of elimination method, so I'm going to choose to eliminate my z's. So I'm going to multiply both sides of this top equation by a 2. That'll make it 8x plus 2z is equal to 12, which my z's will cancel. And then I can continue on to have 19x is equal to 38. Divide both sides by 19, and my x is a 2. We're going to substitute that x back into your equation. Let's see, how much room do I have? Oh, I'm pretty good. So I'm going to sub it into that top equation. 4 times 2 plus z is equal to 6. So I have 8 plus z is equal to 6. So z is equal to -2. That is now my second variable. Keep in mind, I have 3 variables to solve for. Now, what we're doing is actually something called backwards substitution. I solve for one variable, I plug it back in, I solve and get the next, and now I'm going to have to go get your y. Now, how are we going to get your y? Well, your y variable, we're going to choose from the original 3. Now, you get to pick of those equations which one looks best to you, and then go ahead and solve. Now, my last class chose to do this middle one right here. So we're going to pick that middle one where we have x minus y plus 2z is equal to -3, where we know x is equal to 2 and z is equal to -2. So you have 2 minus y plus 2 times -2 is equal to -3. Negative y, 2 minus y minus 4 is equal to -3. Negative y minus 2 is equal to -3. Negative y, we're going to add 2 to the other side, and then divide by the negative. And there is your third variable. Now, these are the point at which all 3 of your equations are going to intersect in your graph. And your point of intersection, we're now on a 3D model and a 3D scale. We have x, comma, y, comma, z. So if it does ask for a specific point, your point would be labeled in terms of like descended. So alphabetical order. So if that made sense, try to pause the video and repeat those steps. Now keep in mind your equation, if you get lucky, unlike us, we actually had to work with two equations. If you get lucky and you already get one of your solutions, treat that as your new equation. So just as you did before. So hopefully you paused the video and now you're coming back to watch how we can solve this one. So we have 3x minus 4y and all of, don't know why I'm reading all that. That would take me forever. So my previous class, they went ahead and selected this first one and this last one. So that's what we'll do here to start. Okay. So they chose this one. Actually, all of your variables here look really good as far as like how we can cancel. Now they chose to cancel out their y values. So they chose to cancel out their y. So we are multiplying this expression by a 2. So 3x minus 4y plus 6z is equal to 10. And your new one is 2x plus 4y minus 6z is equal to 0. Now, you may have been in the same boat where when you picked some variables, they actually canceled out more than one variable. So your x or your y's and your z's ended up canceling. And when we continued, we get 5x is equal to 10 and x is equal to 2. Now, this does not look like one of your new equations, but what this is actually a solution. We're still going to treat it though as a new equation and then keep it for now. So let's keep going. Let's pick 2 more. My students from last semester picked these 2. So we're going to do that one more time. They did 2. They are forced, if they're originally, they were trying to get y to cancel, they're again forced to get your y's here to cancel. You could also try to get your z's to cancel on this side too, because both of them canceled. It was just kind of an anomaly. But notice that 5 and 3, they don't have much in common. So let's try and stick with the y. All right, let's multiply both sides by a 2. Get 2x plus 4y minus 6z. All right, so your y's cancel again, and unfortunately, your z's do not cancel. That is okay. So you have 4x minus 11z is equal to negative 14. Now that does look like one of our saved equations, and now we're going to bring them together. By bringing them together, we have x is equal to 2, 4x minus 11z is equal to negative 14, and we already have this x as your solution, so we can go ahead and plug it right in. We do not need to do chapter 2.3. Instead, we just plug and go. We're going to add your 8 to the other side, or sorry, subtract your 8 to the other side to get negative 22, where c is equal to a positive 2 this time. All right, so you have 2 of the 3 solutions. Let's go back and get the remaining. So figure out which equation looks best to you. My students chose the very bottom one, where we know that x is equal to 2, z is equal to also 2, so there you have your third equation. So, third solution. So if you wanted to, you can write it out in as a point of 2, 2, 2, and 2. Now, if that seems like a lot of work, what we can do is actually do it in your calculator. Now, we don't have a 3D calculator, so instead we're going to have to come up with a different method. Now, if you like this method, you can certainly do it for those that are doing chapter 2.3 homework. Feel free to use this one. Now, we are going to be using something called a matrix. Now, there is not an app for the matrix Desmos calculator. And in this video, I'll do a matrix Desmos. And then in a separate video, I will do it one more time, but with a TI-84 calculator. So one thing with your matrix calculator, we need to go from this equation here to have 3 equations and actually make it into a matrix before we get started. So instead of solving by hand, we can also use a matrix. So step 1, take all of the coefficients and place them into a matrix. And so essentially drop all of your variables. So we are going to build a matrix. Oh my goodness. Oh man, come on, one more time. Oh, horrible. All right, so looking at all of your all of your coefficients from above, we're just going to write them as you see it. We're going to essentially drop all of your variables. So in this first equation, we have a 2, a -3, a 1, and then a -1. You can put an equal sign here if that helps you kind of orient yourself, but we will be dropping them. Let's do it again for your next equation. 1, -1, 2, and -3. One more time. 3, 1, -1, and 9. Let's close this matrix. Now, what we have done is that we have taken all of these x coefficients here oh, come on. All of these x coefficients here should align with all of these x coefficients here. What is wrong with my pen? Why isn't it making it look better? There you go. We've also taken all of your y coefficients and making sure that that all looks good. All right, I gotta reorient this pen, obviously. Okay. Your z's as well. Z is over here. And we're going to erase this equal sign. And then all of your solutions on the other side should be as followed here. So this should be your x's, your y's, your z's, and your solution. So just taking your coefficient, dropping the equal sign, and placing it in. Now, we're going to go to Desmos Matrix. There's no app for this. Instead, we have to go onto your laptop or onto the internet. So figure out how many rows and columns your matrix has. So we have a blank by blank. Your rows are always going to be in the first value here. So how many rows do you have? We have 1, 2, 3 rows. So we have a 3 here. So it's a 3 by, and then your next value is your columns. So your column is 1, 2, 3, 4. So when we go to do it, we're going to open up a 3 by 4. So let's enter in your matrix above. And we do have the remaining of the Desmos steps if you need it. So we're going to go ahead and enter in your matrix. Now I have already entered in our matrix, but down below where it says edit matrix A, you can, if it's not showing, just hit the new matrix button and then use the plus and minuses to add and subtract your rows and columns. So we have a 3 by 4. We've entered it in. We want to double check that all of our values are correct. Otherwise, it's going to spit out the wrong answer. Now, once you have entered it in, you're going to go ahead and hit enter. Now, when you hit enter, there's a bunch of different values that come up underneath the new matrix. Now, we're going to hit the one that says RREF on the very bottom left corner. Now, what we're going to do now is we are going to take your A matrix, your whatever matrix you have labeled. If yours was in B, you can have a B matrix, but ours is in A. We're going to close your parentheses, not that it matters. But to the right is now a new matrix. So this new matrix, I'm going to put down into your box here. So your new matrix, we have a 1, 0, 0, a 0, 1, 0, 0, 0, 1, 2, -2, -1. Now keep in mind, we said from the above that this pink column are your X values. These ones are your Ys. These are your Z's. And these ones are your solutions. So if we're looking at all of this first column, there's only one X value. This X value is 0 and this X value is 0. And across from this one is a 0Y and a 0Z, and then it's your solution. Now keep in mind, we erased those equal signs. If we wanted to bring them back, they would be between your 0 or the Z value, the Z column, and your solution column. So to read this solution, it just is taking that 1X is equal to the 2. And you could say 1X plus 0Y plus 0Z is equal to 2, but we don't need that. So instead, it's just the 1X is equal to 2. So X is equal to 2. Let's try it again for your next one. So equals, so this being your Y column, there's no X values, there's no Z values. So instead we have 1Y is equal to -1. And the remaining, we have 1Z is equal to -2. So these come out to be all of your solutions. So it says each row should have 1 and 2 zeros and then a number in the last column. The column 1 is your X values, column 2 is your Y values, column 3 is your Z, And the last column is your solution. Pretty easy. Now let's try again with your next example. So definitely pause the video and try the next one or two on your own. So let's go ahead and build this matrix as we did before. So this matrix, we have 1, 0.10, 1, 1, 0.08, -1, be careful with all of the zeros. Okay, so this is what your matrix should look like when you go ahead and enter it in. Now I'm going to put that into the next one over here, and notice that it is aligned with what we had just, what the screen we had previously. Always double check that your answers are, that you've inputted it correctly, especially with how many zeros and negative values they are. So when you're here, you can just hit the enter button and it'll move down, and then we're hitting RREF and then getting your A. To the right, it is all of your values. So let's go ahead and transfer that on to here. Then we had 65. So if that's what came out, we have X is equal to 65,000. Y is equal to 45,000. And Z is equal to 40,000. All right, now if you haven't paused the video yet, definitely do so. I'm just going to give you the answer for you to double check. 1, 2, and 3. Now in your homework, if you encounter it, you may not. I think I've taken them out at this point, but just like in chapter 2.3, we can certainly have different types of solutions. The ones that we've been working with have been those unique solutions where they're intersecting on at some point in time. Now, dependent solutions is another way to say it's the same line, which is infinitely many solutions. So the same exact line. Now, notice here that when for one of these examples, if we were to put them into the matrix calculator, this is what your answer would look like. And to figure out if it's a dependent solution, so an infinitely many solutions, we have a bunch of zeros coming down. Now, what this means with this row of zeros, it just means that they want us to say, well, Z is going to be for now equal to itself. We'll figure out later what Z is. So future us is going to be prepped for the future. So that's going to be your first line, whereas your second line, we now know is 1y minus 3z is equal to -56. So we're going to be building an equation for each of your lines. So then this last one is just 1x plus 8z is equal to 23. So when we go ahead and pick out a certain solution that we want, let's say z is equal to 0, then we can go ahead and just plug in a 0 and we would come up with your solution. Or perhaps it's a -1 or a 2. This is just setting us up for the future where we're going to be building now equations because these are infinitely many solutions. Now, the opposite is true for any sort of one that is called an inconsistent solution, parallel lines, which is another way to say no solutions. So a no solution. And you'll notice that how to determine it's no solution is to have something like the below here, where we have 0 is equal to 36. Is that a true statement? No, it is not true. It does not, it does not mean much of anything. So if you see that in the future, that just means no solution.